We are going to find the flux of this vector field through this cylinder. We have a cylinder radius 2 going from 0 to 5 in z. We have a vector field, and we would just like to find the outward flux. So the outward flux is done through surface integrals. That's how we find the flux. But this surface has three components. It has the bottom of the cylinder, the top of the cylinder, and around the sides of the cylinder. So to find the outward flux, we actually have to do 1, 2, 3 surface integrals. We'll parameterize each surface. We'll get the normal vector for each one. We'll go through the whole deal of figuring out parameter domains and endpoints of integration. And then we will actually do the 3 surface integrals to find the outward flux. That is rather onerous, and we would love for there to be a better way. And there is, in fact, a better way. So we're going to use the divergence theorem instead of going through this process. And the divergence theorem in this problem tells us that we can instead just compute the divergence of our vector field. And divergence isn't so bad to compute, right? We have the x derivative of y plus the y derivative of y times z plus the z derivative of z squared. And so the divergence is 0 plus z plus 2z, which is 3z. So that's the divergence. Instead of finding the surface area to find this flux, we can instead do a triple integral over that whole region of 3z. So we'll do a triple integral instead of 3 separate surface integrals. Triple integrals aren't always easy, but in this case it's not so bad. It's a triple integral and it's reasonable, and the region is not so bad. This is a triple integral that we definitely want to use cylindrical coordinates for. And we use cylindrical coordinates here, and we will have 0 to 5 for z. For r, we have 0 to 2, and for theta, 0 to 2 pi, going all the way around. And theta, looking down on this cylinder, it's a circle of radius 2, and so that gives us our endpoints for the polar portion of the cylindrical coordinates, and we have 3 times z, r, dz, dr, d theta. And this is a totally doable integral. There's just power rule involved and constant endpoints of integration. What it ends up with is 150 pi. And that is the outward flux. So instead of doing the outward flux through surface integrals, we switched it over through the divergence theorem to a triple integral. We did the triple integral, and it's a relatively straightforward process instead of a very involved one. That's it.